Hello, welcome to a coding challenge Fourier series. So what I am going to program in JavaScript using the P5.js library is exactly this. This is what's known as a Fourier series. It is a series of wave patterns that when summed up together approximate some other function. What does that even mean? So first of all, I'm going to show you some resources, the things that got me thinking about this topic and wanting to make this coding challenge. And you probably should, if you want, stop this video and go look at these other resources, and then you can come back if you want, or maybe you're just off doing something else. So pretty recently, Smarter Every Day came out with a video called What is a Fourier Series? Explained by Drawing Circles. This video reminded me of an amazing video that I had watched at some point in the past, I guess like almost a year ago, called What is the Fourier Transform? A Visual Introduction. You've probably, if you've done any coding and programming, you've probably heard these terms before. FFT, Fast Fourier Transform. It's usually referenced in the context of analyzing sound. And so Smarter Every Day's video was a collaboration, worked with a Turkish researcher on this website here. I'm not going to attempt to pronounce it. I will. bilimnezguzilan.net. I encourage you to check out and read this whole article. But this is a visualization, again, of exactly what I want to do. A series of wave patterns visualized as a path along a circle, periodic functions summed together to approximate a square wave. And if we can make this happen in JavaScript, then there, in theory, is no reason why we couldn't then figure out how to draw any given path as a series of Fourier transforms. And there's like a sort of well-known GIF or video of this like crazy set of circles drawing Homer Simpson. So I'm hoping to get there. But this video, I just want to, by the end of this video, have exactly this pattern in JavaScript. Okay, so I also want to reference this website, betterexplained.com, which has a nice article, an interactive guide to the Fourier transform. This, I think, is a really excellent explanation. So again, I'm going to start coding in a second, but you're just going to have to humor me to let me kind of talk about this a little bit more, just to get my feet under me here. So the idea of a Fourier transform, so a sound wave, right? We have this idea of a sine wave. You've probably seen me draw sine waves on the board or in code in countless videos, usually drawn something like this. A sine wave has a frequency, which is how often does it repeat? Like if this is the sort of x-axis, like this is one whole cycle, right? And I could think of that as like the time it takes for this circle to this dot to go all the way around the circle. So frequency is like how many cycles of the wave per unit of time, like per second or per frame. There's also amplitude. Amplitude is the height of the sine wave. How much distance between the very top and the very bottom. And so a sound can be represented as a sine wave. But you probably have seen like, oh, I've got this recording device soundy thingy, and what it's doing is it's like, this is like the sound, this is the wave, this is the representation of the sound that I'm listening to right now. Well, you can create, this kind of wave pattern is typically actually the sum of multiple wave patterns. So in other words, if this is like the musical note A, and then this is like the musical note something else, and we're to add these two waves together, can you still see where I'm drawing? You know, I might get something that looks like this. Right? And I've done this, I think I have like an additive wave video in the Nature of Code series about this kind of idea. The idea of the Fourier transform is, can we go, right? I could have these two waves, I could add them together and get this pattern. Could I go in reverse? If I'm listening to a sound like this, could I pull out all of the waves, the sounds, the frequencies that make up that? That's like pitch detection. Or if I wanted to then filter out a very high-pitched sound, if I could take the sound, break it apart, take away one of the high-pitched sound, add it back together, I would get this. So this is akin to, I love this metaphor here in the Better Explained, of unsmoothieing a smoothie. So I like to make smoothies, actually, little known fact. I was like, anyway, so, but could you, like, right, let's say I take some mango and some kale and some blueberries and some like almond milk and I mix them all together and I give it to my children and I say, I made you this beautiful smoothie. Can you guess what's inside of it? This is actually a game we actually play at home. I'm just realizing, oh, this is perfect. Well, if I could do a Fourier transform, I could take the mixed smoothie and filter out, go in reverse and find out all the ingredients. That's the idea. So that's the idea of a Fourier transform. That's conceptually what it is. Now, what I want to do in this video is I'm not going to worry about figuring any of this out. Now I understand what it is, what it can be used for. I have this goal eventually of having it, using a Fourier series to draw any arbitrary path. But one way to get started with that is exactly what's demonstrated here on this website, which is what waves do you need to add up together to end up with a square wave? And you can see here, this is actually a really nice visualization as you have more and more iterations of the Fourier series, how it converges even closer and closer to this square wave. I can also just go here to Wikipedia and find this again. So this is the clue. So there's this idea in a Fourier series of Fourier coefficients and some kind of like iterative thing of like n and n plus 1 and n plus 2, and we can actually see a nice clue to that in here. This is actually this is one of the simplest Fourier series. What is the series? 1, 3, 5, 7. Can you guess the next number? 9, right? And what's after that? 11. So if I can just implement this, each one of these circles and like have them rotate around like this at that period or frequency with that amplitude, we're going to get somewhere. So I've talked about this for way too long. Let's try to actually code this now. So the first thing that I want to do, I'm just going to start, like kind of even not thinking about the Fourier series, and I'm just going to make up a variable called angle. You can really think of that as time. It might be more appropriate for me to call this time, because time is moving forward. That's a sort of crucial idea. And then I'm just going to say time equals, every time through draw, if you haven't worked with P5 before, draw is a function that loops over and over again. So time is moving forward. Then what I want to also do is I just want to like draw a circle somewhere. So I'm going to translate to like 200 pixels over and 200 pixels down. I'm going to have this idea of a radius. Like the radius of a circle that I want to draw is maybe going to be 50 pixels. And then I'm going to say ellipse. At 0, 0 with that radius times 2, because the ellipse function expects a diameter. Radius is half that. I'm going to make this white. So I'm going to say stroke 250. Stroke 255. Somebody told me how to get rid of that autocomplete, and I still haven't done it. And no fill. So when I go back to the browser and refresh it, I've got a nice circle there. Let's make it a little bigger. All right. So now what I want to do is, how can I have that dot traveling around the circle? Let me have the dot traveling around the circle. So the way that I would do that is I would use a polar to Cartesian coordinate transformation. And I certainly have a video that talks about how to do that. But what I'm talking about here is if this is the radius and this is the angle, which is really in my program the time, how far over in x and how far over in y can be calculated, how far up in y can be calculated based on trigonometry. So the radius times cosine of the angle, or angle is the x value. The radius times sine of the angle is the y value. So I'm going to do that here. I'm going to say let x equal radius times cosine of time, and let y equal radius times sine of time. I should probably pause and turn that off. But let me get through this first. Point x, I'm definitely going to pause and turn this off. Point xy, I'm going to say stroke 255, stroke, actually let's make this a circle also. So we're going to say like ellipse xy, we're just going to make it smaller, like 8 pixels, and let's also say fill 255. Oh my God, this is making me crazy. And here we go. Look at that. There's that circle moving. Right? That circle is moving, and maybe it makes sense to also draw a line from 0, 0 to xy. And now I've got this, and I want it to move a little bit faster. And honestly, I'd like it to go the other direction. I'm not sure. I should actually check. What is it doing? If I want to like recreate exactly what's here, yeah, it's moving the other direction. So I've got the beginnings of this. Now I haven't worried about the number 4 here and the fact that I've got the angle divided by pi, but we'll get there. I'm back. I fixed this autocomplete thing that was bothering me in Visual Studio Code. I'll put something in the description about how I did that. But I also wanted to mention in the chat, thank you to Amr who wrote, you are using Fourier series and Fourier transform interchangeably, but they are not the same thing. So thank you so much for that comment. I will post some links also in the video's description for more reading about this. But in short, the Fourier series is for periodic signals, which is what I'm doing exactly right now to create this square wave, which is periodic, versus the Fourier transform, which is for aperiodic signals. Another way of thinking about that is to represent any general non-periodic function. So hopefully as I get further down this road, I will come back to this. But, and also in the chat, Smarter Everyday writes, Fourier transform is for swapping between frequency domain and time domain, which is also a really nice way of putting it. Okay, but what I am doing in this video is implementing the Fourier series, the periodic series of that add up together to the square wave pattern. Okay, so here we go. So I have success step 1. I have my circle passing around, and you know what? I think that I probably should. I think that I probably should not put this. I'm going to have this not go the correct direction. I'm going to have it go this, because I don't know if the negative number is going to mess things up there. Okay. All right, next up. Next thing that I need to do, and if we go back to this particular video, is how can I take this circle that's moving around and then draw the resulting wave pattern. And this is actually kind of a much simpler problem than you might think, because basically what I want to do, this is moving in 2 dimensions. X is oscillating back and forth, Y is oscillating back and forth, and both those oscillating at the same frequency with the same amplitude in the same phase, the starting together, is moving along the path of the circle. So I just need to take the Y value and sort of graph that along the X-axis. So the way that I'm going to do that is I'm going to add an array to my code. I'll call it wave. And it's going to be an empty array. It has nothing in it. And what I'm going to do here is every time I calculate a new Y value, I'm going to say wave push Y. So I'm just going to save that particular Y value. So now all I need to do is say, for let X, I'm not going to use X, I equals 0, I is less than wave.length, I plus plus. Let's draw a point at I comma wave index I. Right? So all I'm doing here is saying, let's just draw all of those height values, those Y values, from kind of X equals 0 to as many of them as I get. So if I do this, you're going to see, look at that. There's that wave pattern going. All of those points are moving up and down. And you can see how the height of that wave is the same as the thing passing around. Okay, but this doesn't look so great. So what I want to do is I want to instead use begin shape and end shape. This will and then say vertex. So this will actually like tie it all together. And I think if I say no, it's actually I'm going to leave the fill in there for a second because it's kind of cool. So that's actually like trying to fill in the shape, which is a sort of a nice pattern. But I'm going to just say no fill. I'm going to do this, refresh the page. And then also, why not translate, just to translate this a little bit over, like 200 pixels. And we can see this. And then I guess I could also draw, sorry, I want to draw a line. Yes, I want to draw, sorry, I got confused what I was doing. I want the end of the line to connect to where that is. Oh, of course. Okay. So what I want to do is draw a line. So I need that first, I need this first value. So I have x minus 200 comma y to I comma wave index 0. And actually it's not I, it's 0. So this is just, this I know is the very first point in this loop. And since I translate it over, I've got to like back up with my x value. This is very awkward. Oh, no. I don't want it to connect to here. What am I doing wrong? Why is what I'm doing different? I'm doing it backwards. I know what I'm doing. I'm doing it backwards. I actually don't want to, I'm appending to the end of the array. So every new value I'm appending to the end, I want to add it to the beginning. So instead of using push, there we go. Instead of using push, I want to use unshift. So unshift is a JavaScript function. It's a weird name for it, but push just adds this thing to the end of the array, and I want to add it to the beginning. Oh, that was a mistake. There we go. This is what I'm looking for. There we go. Okay. So now I have the line connected there. Now, the one thing that's a little bit of an issue here is that I'm just like adding points and adding points and adding points and adding points and never getting rid of any points. So I also should probably, at some point, I should say something like if wave.length is greater than like, I'm just going to make up some number right now. I could do a calculation of how many points I need till the end of the canvas, but just to move more quickly here, I'm going to say wave.pop. So that would just like, if it's getting more than 500, it's going to like delete the last one off the end. And now we should be able to say like, I should be able to look at wave.length. It's 152. So clearly I only need like, I don't need more than 250. All right, we are at this spot. Now comes the exciting part. I mean, this was hopefully all somewhat exciting, but to me, how do I suddenly go from I have one circle with a point around it to another circle that's kind of like there with another point around it to another circle that's like there with another point around it? How am I going to add up these circles and continue this path of x, y along them with all of these points rotating and spinning? And guess what? I've actually done this before. I'm just remembering now. I have a video on the fractal spirograph. Let's see if this comes up. Yeah, the fractal spirograph, I actually did this already in the fractal spirograph, which was this way of doing exactly this to create a fractal pattern. I should go back and revisit this. So we'll see if how this compares to that. So let me go back to the code here. And so what I want to do, so first of all, before I do this, I think I need to think a bit more formally about these functions. So before I was just saying radius cosine of time, radius sine of time. But these functions actually map to these values on Wikipedia here. So if theta is my time, basically, what I'm saying is that I want to, and the value multiplied by that is 4 divided by, sorry, theta is my time, and 4 divided by pi is basically my radius in a way here. I'm kind of conflating some things, but I can start to use this particular series to understand the ratio of the radii and the frequencies between these different oscillating circles. Okay, so let's say, what I do is I say 4 divided by pi times cosine of, what was it again? 1 times time. So I'm going to do this. I'm going to just change the y here. And then what I'm going to do is I'm also then going to say radius times that. And also, I missed something. 4 divided by what? 1 times, this is confusing because there's a 1 here. 1 times angle, 1 times pi. So I'm going to say and that's 1 times time, and this is 1 times pi, and this is 1 times pi. So the number that I need to change for each circle is that 1. So let's just see what this actually yields. And I'm going to go back to here. It's the same thing, but now the fact that that radius was 100, it's like everything is way too big. This is going to get calculated here. I will refactor this later. Let's put this in here, and then let's make this back to this, because I don't really need, let's make this back to here. Okay, and 4 times divided, this should be 1 times pi. Why is it doing that to me? I don't want that far. I want these divided by each other. Visual Studio Code is too smart for my own good. There we go. There we go. That's what I wanted. That's why it was giving me something crazy. Anyway, okay. Radius is not defined. Now I need to draw the circle next. This is when things are going awry. And let me put this here. There we go. And now, there we go. Of course, now it's this time. Of course, I had the division in the wrong place. I have this tiny little wave. So let's go back and make that about 25, which I think would be now basically like, oh, but it's divided by pi. Ah! This is going remarkably well. There we go. Okay, I'm happy where I am now. Okay, so now I have that first circle. The reason why I am doing this, the reason why I'm putting this, making all this work, because I want this to be n. I actually want this to be a number that changes, right? First it's 1, then it's 3, then it's 5, then it's 7. That's not too hard to figure out, right? And what I want is to start x with and y both at 0 and just add this stuff together. So x plus equal, x, y plus equal. So I want to, and then what I want to do is I want to loop n. So n is going to go from 1, I'm going to say 0 actually, n, because you got to count starting with 0. n is less than 2, n plus plus. And then, and this really, by the way, I should call this I, because what I'm really saying is, n is, how do I do 1, 3? I mean, this is pretty easy. I multiply by 2 and add 1. n equals I times 2 plus 1, right? When I is 0, I get 1. When I is 1, I get 3. When I is 2, I get 5. So now if we add these together, and I'm just doing 2 right now, and speaking of which, I should move this all the way down to here. And I'm going to take this out for a second. And then I got to go back here. And there we go. Okay, so something is wrong. I kind of got things close. Like, look at this interesting, weird, crazy pattern that I've got. Okay, so the line should not be going from, so I should be actually keeping track of previous x is x and previous y is y. So I'm going to like take out the wave for a second because I'm going to have to change what I'm doing here. And then I'm going to just say previous x equals x. Oh no. And then previous x equals x, previous y equals y, and then the line is going from those. Like it's not always going from 0, 0, it's going from the previous xy. So now that's right. The other circle also needs to have its center be at previous x, previous y. And there we go. So now I have this. I have this circle spinning around this circle, spinning around this circle. There's only 2 circles. But in theory, if I change this to like 5, there we go. Now we're getting somewhere. And actually, it would be sort of fun. I really think that I should think about how I'm drawing this a little bit better. So for example, I think I want these circles to be much lighter. So let me give them a little alpha. And then the points should also be, I think the points are almost like less relevant. I almost don't want to draw these points. Let's just, because I have the lines now. So let's see what happens if I take this out and I do this. Oops. But I want the line to be full brightness. There we go. So this is what I'm looking to draw. So there we go. So I now have this particular series with every circle next to rotating around every other circle. And I am using the values from the particular Fourier series for a square wave. Okay, so now, and I feel like this should be bigger. It's so small. Let's go back to having this be 100. And let's actually not, let's just see how this looks. And we can also, I'm being like neurotically silly about, let's move it over a little bit. Okay. Oh, I don't want it to go off the screen though. So let's leave it there. Split the difference, 75. Okay, and then I have to go back a little bit. This is very silly what I'm doing. Okay, there we go. I have a problem. 150. There we go. Okay, so I know this is hard for you to see. Let me zoom in on it. So this is where we go. So now, guess what? We're basically done. right? Before, I just had to put the wave back. Let's see what happens if I just put that wave back. Like, what happens? If I put it back, well, what's going on? Like, I'm getting some crazy thing here. I don't even know what's going on. Oh, I'm pushing all the values. I just want to push the last value. Actually, this is going to be a much easier fix, I think. I just want to push the last value after the loop is over. And there we can see, there we go. But I don't know why this isn't shifted over. Did I lose that somewhere? I need to do this. This is actually going to be, all of this was actually fine. And there we go. We are done. I should add one more thing to this because this is going to become relevant later in my mind's eye of how I'm going to do more videos on this. So right now I am visualizing the resulting wave pattern. Also, I got to do a few more things. Will you please bear with me? I know this video is already about 70,000 hours long, but let's at least add one slider. And I'm going to use the, and so I'm going to have a slider that gives me values between 1 and 10, and I'm going to start it at 1. And what I'm going to do is I'm going to take a slider.value. So basically, I'm going to have n be slider dot. I'm going to have n control the amount of iterations of the Fourier series itself. So now you can see there's just 1, so I can use this slider to add 2, 3, 4, 5, 6, and this is 10. And this is fun that I can actually do this in real time. So now you, the viewers of this video, will have so many more creative and interesting ideas about how to make this prettier, how to create more interactivity. There's so many, but this is just an inkling, right? Every system that you build with code has a bunch of variables and parameters. There's no reason why you couldn't make those interactive. You couldn't even, like, we could make the number of iterations map to a sine wave itself. Like, what would happen there? That would be crazy. But now you can see up to 10, we can see how it's converging. And I don't know how far I want to push this. Let's push it a little. Let's try. Let's put it at 100. Okay, that's 0, all the way up to 100. Performance-wise, it's fine. It's happy to do 100. There we go. Look at this. Look at that square wave. Oh, that is like the nicest square wave I've ever seen. This is making me so happy. I cannot explain to you. I feel like this is a thing that's been in my head for years, but I've never actually sat down to program it. Of course, I am standing right now, but close enough. Thank you for watching this coding challenge visualization of the Fourier series for making a square wave. Check this video's description for a link to the Coding Train webpage with this challenge and the code for it. And then if you make your own variation of this, please share it with me. You can contribute it right there. So what are some things you might do? Number one is, why don't you try doing this sawtooth wave? Could you take the code that I wrote and make it do this? That would be a nice exercise to try. What other kinds of interactivity can you add to this in terms of changing the colors, changing the different parameters, changing the view of it? What happens if you do this in 3D? Right? Could you have some kind of point oscillating over 3 dimensions in a sphere and then map that to something? That would be cool. So I look forward to seeing what kinds of things you create, ask your questions and all that nonsense. I mean, it's not nonsense. It is, whatever. Goodbye. See you next time.